everyone. Welcome back to my math teaching online again. In this video, I will continue with the antiderivative, which is the second fundamental concept in calculus, moving backward. So before we move forward, we do derivative. Now we go backward and do antiderivative. So let's get right into it. So on my dry board here, you will see I wrote down a bunch of formula, right? So this is just the basic symbol formula, some basic symbol one. Now the list is a lot, right? And I will upload the file with the list of formula of antiderivative for you. If you register into my course, you have access to the file with all the formula. At this moment, we just try to touch the surface of what is antiderivative and how we're going to apply the antiderivative to solve some of the interesting word problems, the application, motion, economic, finance, blah, blah. So today, I just want to show you how to differentiate some basic function. This particular topic, because this is the second level course, it gets into a little bit tricky for the iteration. Even though we have a formula here and we apply it, but we still have to use some kind of background in the past we learned in quadratic function or anything we learned in the past, so that we can manipulate and we do the iteration. That will get into iteration by parts and iteration by substitution, blah, blah, blah. So for this chapter 1, I will upload the practice exercise for you to practice some maybe a page of antiderivative, so that you know what it means and you will apply it to solve the problem, the word problem. After I'm done with the chapter of application of word problem, we'll get deep into the iteration. And at that time, we'll learn the formula, how to use the substitution rules, iteration by parts, and find the area under the curve, blah, blah, blah. So that will come later on. So now let me show you how to do the antiderivative of some function, and so that you get some idea and you get familiar with it, so that we can get into application. But again, I said that we'll get back to the iteration to get deep into the how to do a lot of word problem. How to do a lot of iteration, not just like the one I show you today on the board. Okay, so let's see how we're gonna do it. I have a function f prime x equal minus 3 cos phi x plus a sin x. So now in the textbook, you will see they just put f of x, but actually they assume you to know that this is not the original function, it's the derivative function. And we want to get back to the original function. So that's why I put the formula here. This is y prime, and this is y. This is y prime, y prime, y prime. On the right-hand side is y, right? So if we have a cos kx, the formula say the y will be equal to 1 over k sine kx plus c. If we have y prime equal sine kx, the original y equal minus 1 over k cos kx plus c. So let's apply that and do it here. So now our big derivative, big function, original function will be minus 3 over, the k here is 5, so it will be over 5. And cos, the antiderivative of cos is sine phi x. So we're done with this one. Now we go to the next one, will be 8, just a. The antiderivative of sine x is minus cos x. So we time with minus cos x. But remember, the positive time with negative, we change it become a negative. And we can write them like this. And don't forget plus c, right? So we're done with the first question. Now, go to the next question. If we have a function, derivative function is minus 1 over x to the power 4, adding with x to the power 3, adding with 4 over x to the power square. So how we deal with this? Now the easy way is we just bring the x down here up to the top. So I haven't done anything yet. I just rewrite it, right? We'll rewrite this in terms of minus x to the minus 4. Remember when we bring this to the top, we have to change the positive power become negative power. Adding with x power 3, adding with adding with 4 times with x to minus 2. Okay, so now we rewrite like this so that it's easy for us to do antiderivative. So our f of x original back to the original function will be minus 1 over, now add 1 into this, minus 4 add 1 is minus 3. So we have a negative come from here and we have minus 3 down here, negative as well. And this x will change it become minus 3. Adding with 1 over 4, x to the power 4, right? Remember we add into 1 in here and then divide by 1 over n plus 1. In the first lesson, I show you how to do that already, right? So now we should apply it. And this will become adding 4. This minus 2 add to 1 will become minus 1. So 4 divided by minus 1, x to minus 1. So let's simplify one more. This negative divided negative is positive. Now because this is negative power, I'm going to bring this down, right? I'm going to bring this down and I'm going to change it back into x to the power 3. Adding with, you see no change, we can rewrite this like this as well. Okay, and this positive divided negative is negative. And we have 4 on the top, but I'm going to bring this power down, become like that. And let's see. So that's how we do the antiderivative of this function. Okay, so now let's give you another example. So that's the question 2. Now question 3. Let's say you have something weird that is my own traditional way of teaching. I'm not so good at using the computer and blah, blah, blah. But you know what? As long as we can learn math, right? That's my excuse. Okay, so let's get to the next question. We're done with that one. Now we're going to do a weird one here. And what number is that? Number 4, maybe? So number 4, we have a function where 1 over square root of 1 minus x, adding with 1 over square root x. Now, I'm going to rewrite it fx equal 1 over square root x, adding with 1 over 1 minus x. I don't know if you can see. This is, the ink is not a good ink. I cannot see very well. Okay, so I just put the easy one in front, right? Nothing changed yet, okay? So now I can bring this up, right? So my new fx will actually the same, right? Nothing changed. It's just I rearrange them, rewrite them in another way to make it easy for us to do antiderivative. So remember, I can bring this up, become minus 1/2 rational power. Now adding with this is a little bit weird because this is the whole expression. So I'm going to substitute this by u, okay? So I'm going to rewrite this as u 1/2, right? And I just say let this bracket, right, plus 1 minus x equal u. So just the way I draw it so that it's easy. It looks simple, right? So now I can bring this up as well, right? So that will become plus u minus 1/2, okay? So now our antiderivative, big original function will become 1 over, now minus 1/2 add into power 1 will become 1/2. And 1 over 1/2 is just 2, right? And x to the 1/2, right? Minus 1/2 at 1. And now this 1 can do exactly the same, will be 2 u 1/2 plus c. So now because we do antiderivative, we have to have plus c in there, right? So now we can rewrite this as square root of x, back to the same. This we can rewrite as square root of 1 minus x and plus c. So that's how we done, okay? So that is another question. You see that, how we do it. Now I'm going to do a next question. Next question, let's say if you have fx equal e to the ln x. If you learn math 12, right, you know that e to the ln x equal x, if you learn math 12. And I just don't want to explain too much in the formula because it would take away our antiderivative time. So if you still have any question, you register my course, we'll work it out. So what e to the ln x actually equal x, okay? So I'm going to say this one will be equal x, e to the ln x equal x. Now, back into the original function will be 1/2 x squared plus c. So that's how we done the number 5. I'm going to go to the next question, number 6. Let's say you have integration of sine of y over cos square y and dy. And why do we have dy? Remember, if you have an x function, then this is dx. But because this is a y function, so this becomes dy. That's all. They just change the letter to make fun, right? Make some more fun instead of just the same stuff like boring. So they just change the letter a little bit. Everything is the same. So now we're going to integrate this function. Now, because this function is a little bit complicated, so again, I'm going to use a substitution method. So I'm going to say, here you go, you learn a little bit about substitution method now in this lesson with me. But we will get deep into it in the after we're done with the application, okay? So let u equal cos y. So I'm going to rewrite this. Therefore, this function will write as sine y over u, right? Because cos square y, u square. And this still dy. So when I do let u equal cos y, I'm going to take the derivative of u. So therefore, du over dx, no, du over dy will be equal the derivative of cos y is negative sine y. No, the antiderivative, sorry, sine y. And I'm going to kick this dy up here. So I'm going to say time with dy. And cancel this down here. Right? We can do that as well. When we have an equation left side, right side, we do opposite operation. We kick this up and we cancel that. Okay? So now du will be equal minus sine y times dy. Now why I do this? Because if you look at the top of this function, you see what we get. Sine y dy. So now I'm going to rewrite this again. The sine y dy will be just become negative, right? I can put a negative outside as well. Okay? Sine y dy just 1. And I substitute the sine y dy by this sine y dy by just minus 1, right? You see the whole thing here, sine y dy. And down here is u squared. And I substitute sine y dy equal du. See that? Du equal minus sine y dy. Sine y dy. So I substitute this equal du. Okay? And that's our purpose, so that we can integrate easily. So now back into integration, I'm going to bring this up top like that. So our big original function now will become this minus still there, right? Minus. And if I add this into 1, so we will have minus 1. So minus 1 divided by minus 1. And here I have a u to the negative 1, right? Plus c. That's how we do antiderivative. So this will become, I'm going to bring this down because this negative power. So minus times minus is plus, and I'm going to bring this down. So y 1 over u to the power 1 plus c. Okay, now at this point, I can substitute back for the u, right? What is the u? We say let u equal cos y. So that equal 1 over cos y plus c. And 1 over cos y the same like secant y plus c. So we're done with this question. Okay? So you see, this is quite a bit of work, right? You need to practice, right? Because this is calculus. That's why you need time to practice to get used to with it. But very straightforward too. It's just mechanically straightforward. Now, after this lesson today, I hope that you'll be able to practice your worksheet. I'm going to upload to you the practice exercise, and that is antiderivative. So that you can use that as the application. We're going to get into the next video. We're going to get into solve the word problem using antiderivative. So I hope you enjoy my video teaching, and please hit the subscribe and like. Thank you for watching, and bye for now.